Here we are looking at question 4 of the Unit 2 worksheet 2 worksheet, and the question reads: in 1997 a high-speed car of mass 1.1 times 10 to the 4 kilograms achieved the world land speed record. The car accelerated uniformly in 2 stages as shown in the table. The car started from rest. So using the data to calculate the average acceleration in stage 1. So for acceleration, we're going to have our change in velocity over change in time. So for stage 1, we know it started from rest, so the change in velocity would have been 44 meters divided by 4 seconds, so we would have 11 meters per second to the minus 2. The average net force required to accelerate the car in stage 2. Now for this we need to work out our acceleration, and so we're going to have our acceleration, which will be our change in velocity, which is v minus u over t, and that's 280 is our final, minus the 44 is our initial velocity in this stage, and it's going to be divided by 8 seconds because we're going from 4 to 12 seconds here, and that will give us a acceleration of 29.5 meters per second to the minus 2. Your force is therefore equal to ma. So the mass is 1.1 times 10 to the 4 times the acceleration, which is 29.5, and that will give us 3.2 times 10 to the 5 newtons. The total distance traveled, now we know we're going to have to look at 2 sections, so we'll look at S1, and here we can use our formula u plus v over 2 times by time. The u is 0 here, so we're going to get 44 divided by 2 times by 4, times by 4, and that equals 88 meters. And our S2, we got the 44 plus the 280 divided by 2, that will give me my average velocity during that time, times by 8 seconds, and that gives a distance of 1296 meters, and therefore the total is the addition of those two, and that works out to be about 1,400 meters. Now the reason why I've got it like that is that to 2 significant figures, because all my data is in 2 significant figures. You can see this, so I must give my answer in 2 significant figures, also 1,400 meters. So that's for question 4.